Right, guys. Let's go back. So, patterns. If we look at the following thing, a sequence is a set of numbers separated by commas in which that they have each number is formed after some definite rule. So what I mean by that is these numbers 3, 5, 7, 9. There's a pattern to these. Anyone guess the pattern is? Yeah, 2. The pattern is between 3, 5, 7, and 9 is it's going up in 2s. This right here is known as the first term. And what you'll often see in questions and in exam papers is called T1. Is that right? This one is the second term 5. What you reckon it's called? T2, T3, T4, and so on. Is that alright? So, Tn, or the general term, or the nth term. So this has two different n's. It's often called the general term, or sometimes called the nth term. And what that means is, this is a rule that defines the sequence. So for example, when you took the last 3, 5, 7, and 9, that is a rule which lets you find every number in the sequence. Alright? And that's called a general term, or the nth term. So for example, this is the general rule for a sequence. Tn is equal to 2n plus 3. So known as the nth term or the general term, Tn is equal to 2n plus 3. This allows us to find any term in the sequence. So for example, if we want to find the first term, anyone any idea how to find it? I want T1. Remember we said we want to be in T1 and T2? So what are we replacing 1 with inside here? We're replacing with n. So we're doing the exact same thing then over here. We're going to replace the n with a 1. So for example, T1 is going to be 2 times 1 plus 3, which is 5. How will I get T2? Exactly, put in a 2 instead of an n. So T2 is 2 times 2 plus 3. T3, 2 times 3 plus 3. And all the way up. So like if you didn't have this term, as we look there, 3, 5, 7, 9, 11, imagine how long it's going to get to 100 terms. But that's why this rule is so handy. All you have to do is put in the number that you want to find. So for example, the 100 term, T100 is 2 times 100 plus 3, which is 203. Right, with that in mind, I want you to have all this question. Find the first 4 terms in Tn is equal to 5n minus 2. Off we go. T1, T2, T3, T4. All you right, 3, that's a 3, 5, 3, 8, 13, 80. 3, 8. Lovely to see your time is as good as ours. So, anyone know what's happening with this? Goes up in the 5s. Anyone know how before the season started, I knew this was going to go in the 5s? Exactly. That lets you know straight away what's going on. That's very important when we're going to be given the numbers in a minute and asked to find the root. Alright? I knew straight away this is going up in 5s because it's a 5 in front of the n. Is that okay? So, what happens if it goes the other way? So 3, 5, 7, 9, and 11. This time, they give us the numbers and they want us to find Tn. Now, a couple of teachers do it differently. The easiest way to do this is if you follow this now. So we all watch it up. The easiest way to find the general rule or the nth term, or Tn, is we use the formula Tn is equal to Dn plus To. So don't worry about too much about taking out these notes. They all go up in the app. Alright, it's all about getting you to do as much work here as possible, not wasting time taking out notes. So Tn is equal to Dn plus To. Julianne, what does D stand for? Do you remember? I don't know what D is going to stand for. Grace. Exactly, the difference. D stands for difference. So the difference between each one. And TO. I don't remember what I call this one here. This one? T2, T3, and so on, isn't it? So that's T1, T2, and T3. I want T0, the term before the first. So what do you reckon the first term would be? 1, exactly. So TO, D is the difference. TO is the term before T1. My D is 2, because the difference between each one of these is 2. And TO is 1. And that's my formula. That formula right there allows me to find any term. And you can check. If Tn is equal to 2n plus 1, and I say T1, 2 times 1 plus 1 gives me 3. T2 is 2 times 2 plus 1 gives me 5. And we can see that I'm right. That rule that I just figured out right there allows me to find any number in that sequence. You get 2 pattern questions in paper 1. Alright? On paper 1, you're going to get 2 pattern questions. So it's very important to get the basis out right because they're going to get harder than this. Is that okay? Right, I'm going to get you to do an example. Right. How do we go with this one? Find Tn. 5, 8, 11, and 14 is my pattern. Right, guys, let's have a little look at it. So, what is my formula that I said? Tn is going to be equal to what? So, my formula, first of all, is Dn plus To. Before we go worrying about that, we got to make sure we remember our formula. Then, Diarmaid, what did you say my difference between each one is? Good lad. 3, 3, 3. And To, Emer. To is 2. How'd you get 2? Exactly, took 3 away from 5. Perfect. Tn is going to be equal to 3n plus 2. And that's full marks there. Good stuff. Right. Have a go at this one. Another one before we move on to the patterns. Have a go at -1, 4, 9, 14. So find Tn for me. Anyone running into trouble as this? So just because it's a negative number, nothing changes. The formula is still Dn plus To. a little look at so. First things first, we're going to find D. So, Julianne, what's the D? 5, exactly. Minus 1 to 4 is plus 5. 4 to 9 is plus 5. 9 to 14 is plus 5. So the difference is 5. Grace, do you know what TO is? Close, minus 6. You're going 5 back from minus 1, so it's minus 6. So our formula was Tn is equal to Dn plus TO. Tn is now 5n minus 6, and that's our formula. We happy with that, guys? Good stuff. Right, so how does this come up when it comes up in the exam paper? It's going to look a little bit like this question here. So, this is how it will look now if it popped up in the exam paper. A series of shapes are made using matches. How many matches will be needed for the fourth and fifth shapes? And then find the formula in terms of n. What do you think they're actually asking us when they say find the formula in terms of n for the n shape? We're looking for Tn. Alright, so they make the questions complicated when you're in the exam paper. I don't know why. Instead of just going, what's Tn? They try to relate it to real life. So the hardest thing about the exam paper is understanding the question. But that's what they're looking for there. The n shape, they're looking for Tn. So what I want you to do is figure out those two. So count the matches. They're not giving us numbers this time. This is T1, this is T, and this is. So they want you to find T4 and T5. So count the matches and see if you can figure out the pattern T4 and T5. Is that okay? Off you go. First thing I do here is count how many matches here and I go T1 is equal to how many matches is that. And then I count how many matches are here and go T2 is equal to that many matches. Don't forget the second part, get me Tn. Right, let's look at it. So the very first thing I do, step 1, I write down the value of each shape. So there's 5 in the first, 9 in the second, and 13 in the third. So that means in the fourth and fifth, what's going up in? Exactly, going up in 4. So going up in 4 and 4. So the fourth is going to have 17, and the fifth is going to have 21. My formula doesn't change. Damn it, what's my formula? Tn is equal to Dn plus To. Come on, close enough. So Tn is going to be equal to Dn plus To. So that's 4n plus 1. Your difference is 4 plus To, which was 1. Perfect. Right, let's have a go at this. Right, off you go. Have a go at this one. So the question is going to ask us, find a formula to calculate the cost of any children visiting the exhibition. Julianne, what do you reckon they're asking us in the first one, part I? What's the complicated way they're asking us a simple question? Find Tn. That's exactly what they're asking us. See what I mean? They make the questions more complicated than they need to be. So I want you to find Tn for me. For the children. You have 20 minutes down already, guys, we're flying. So they want you to find Tn for calculate the cost. How much it will cost. So for all the world, T1 is 5, T2 is 7, T3 is 9. It's just how it's the exact same question as the last one, just it looks different. Formula hasn't changed. So, find a formula to calculate the cost of n children visiting the exhibition. As I said, T1 is 5, T2 is 7, T3 is 9, T4 is 11. Dermot, what's the difference? 2. Good lad, 2. Grace, what's TO? Plus 3. How did you get 3? You took? Perfect. Tn is equal to dn plus to. The more you write out the formula, the more you remember it. Tn is equal to d, which is 2n plus 3. Dermot, the second part of that question. Any idea how I'm going to verify that formula works for 3 children? You going to help them out, Grace? What are you going to do? Good girl, exactly. We find T3. So we say 2 times 3 plus 3. What's 2 times 3 plus 3? 9. If we go back up here, 3 children cost 9 more. The same if they ask you to verify for 4, Dermot, what do you reckon you do? Put in? 4. Exactly, perfect, lad. Right, one more of those. Slightly tougher. this is like something that will come up now and it'll be very wordy. Right, so we've got to figure out through the words what they're actually asking us. So the question says to us, a taxi charges €5 for a journey of 1 kilometre, €8 for a journey of 2 kilometres, and €11 for a journey of 3 kilometres, and so on. Write out a table showing the cost of journeys up to 6 kilometres. Alright, so we can do the first bit anyway. What's going up in Grace? Not going up once, it's going up for cost. It's going up by 3. Exactly, we earned it. So see how much of this you can get in your own. Alright, I'll be floating around giving you a hand. In for starter. Define TN first of all, before you answer this. And make life a lot easier. Alright, so before you ask the fixed charge and rate per kilometre, find TN and make life easier. See if you can figure out what it is then. So just so we know we're clear in the language. A fixed charge is something that doesn't change no matter how far you go. Whether you go 1 kilometre or 30 kilometres, you're going to be charged this. That is the rate, how much they're going to charge you per kilometre you go. So for example, if you go, for every kilometre you go, they're going to charge you a certain amount of money. That's the monthly rate. It's the English in the question that's going to catch us. Right? That's the hard thing with the example question. It's the English in the question that's going to catch us. Right, let's have a little look at it. So, a taxi charges €5 for a journey of 1 kilometre, €8 for a journey of 2 kilometres, and €11 for a journey of 3 kilometres. So write out a table showing the cost of journeys up to 6 kilometres. So T1 is 5, T2 is 8, T3 is 11, T4 is 14, and T5 is 17, yeah? Right. Treating the cost as a linear sequence, find the common difference. What do you reckon the common difference is there? €3, exactly. Good lad, it's gone up in threes. Emer, were you able to get me what Tn was? Good girl. Tn is equal to 3n plus 2. We all happy with that, guys? Now, Julianne, if I was to ask you what was the fixed charge? Grace, any idea? Anyone able to help us out? What do we reckon the fixed charge is? Let me look at this. Other way around. It's €2. Anyone able to tell me why it's €2? That doesn't change. If you think about it, if you put 0 into that, you're going to end up with 2, aren't you? If you put 1, you're going to end up with 5. 2 doesn't change. Whereas if you take the rate per kilometre, part B, that's 3. And the reason that's 3 is for every kilometre you go, you're multiplying it by 3, aren't you? You go 1 kilometre, you're going to multiply it by 3. 2 kilometres, you multiply it by 3, and you add 2. The 2 is the fixed charge. The last one, IV. How long of a journey can be made with €100? So, the long way to doing that, and I see students doing it, is you keep counting up in threes until you get to 100. The shorter way is you say Tn is equal to 3n plus 2. And we know what's the final outcome going to be? 100. We know the final outcome is 100. So I want to find out, what am I looking for? I'm looking for n, because n is going to tell me the number of kilometres I travel, isn't it? So it's like algebra. No matter how far you run in maths, you can't get away from it. 3n is equal to 100 minus 2. Bring your 2 over. 3n is equal to 98, divide both sides by 3. N is equal to 98 divided by 3. Going evenly. 32.6. 32.6. You can only travel 32 kilometers. You won't get the 33rd one out. So that was linear. Right. Let's have a go at another one type of these. Right, let's look at this. Slightly harder again. So orange and black discs are arranged in rectangular patterns as shown. How many discs will be the 10th rectangle? How many black discs will be the 10th rectangle? What I'm going to recommend to you is count how many orange discs in the first one. So there's a pattern between these, is that right? So it's going up in the same amount. The oranges and the blacks are separate. Is that okay? The orange and the blacks are separate. So get me a pattern for orange, and then get me a pattern for black first of all. So get me Tn for orange, and get me Tn for black first of all. And then you'll be able to answer your question. You're going to get a question. Have a go and get me a pattern for that. Give you 1 more minute of that. Right. Let's look at it so. Right, Julianne, you're going to help me with the first one. So, how many orange this in T1? Orange? 3. Emer, how many orange this in T2? 6. Grace, how many orange this in T3? 9. So, Dermot, what's the difference for the orange this? 3. And what's T0 do we reckon, Julianne? Take 3 away from 3? 0. So my Tn for orange is simply just 3n plus 0, which is just 3n. Is that alright? Right, for black, that was orange, this is black. Emer, what's T1 for black? T2? T3? What's it going up in? 1s, exactly. So what's my Tn going to be? 1n plus 0. Take 1 away from 1, you get 0. So 1n away from 1n plus 0 is just 1n. Right. If I asked you then, Grace, how many discs will be in the 10th rectangle? 40? What do you reckon? Yeah, won't there? Because in the 10th one, it's the two of these put together, isn't it? So T10 is 3 times 10 plus 1 times 10. 3 times 10 is 30 plus 10 is 40. How many black discs in the 10th rectangle, Dermot? 10, exactly, good lad. There'll be 10. Describe 2 ways of finding the number of orange discs in the 10th rectangle. You can count them up, or you could do like we did there. Get patterns. Is that okay? Right. Let's move on to the last little bit in patterns then. So, the last little bit in patterns, small but harder, is this. So, what we've been dealing with so far is something known as a linear pattern. And we're going to move on now to a quadratic pattern. Alright, girls, so why do you think the last one was called a linear pattern? Graphing up the line, because there's one up at the same amount each line, isn't it? This one is known as a quadratic pattern. And the reason it's known as a quadratic pattern is the difference is going up, is doubling each time. So what I mean by that is, what is the distance from 4 to 7? 7 to 12, 12 to 9, and 9 to 8, 9. So it's not the same. The first difference is called 3, 5, 7, 9. It's not the same. If it's not the same, it can't be linear. So the second type of pattern you have at junior cert level is you have a quadratic pattern. And how we know it's quadratic is you check the differences between your first difference. So what I mean by that is, what's the distance from 3 to 5? 5 to 7? And 7 to 9? 2. So we know it's quadratic. That's ticked off. We know it's quadratic. And there's a special formula for quadratic. You just take it out on the top of your copy because you need it for the rest of this. Tn is equal to an squared plus bn plus c. This is the toughest bit of patterns. Alright, not the toughest. It's not the harder chapters, not even get your heads around. Just a little bracket next to it say A is always half the second difference. Alright? A is always half the second difference. The second difference. So for example, on this question, what would A be? Half 2, 1. So the second difference, A is always half the second difference. And this question, A will be 1. Right, so we're going to look how this might come up in a question. So we look at the following. Find an expression for Tn for 8, 15, 24, 35, and 40n. So they want us to find Tn, or the general rule of the nth term, any one of those three, same thing. So there's no need to take this down, guys, you can just have a look up, because it's going to go out the app anyway, and you'll have it when you're doing home. Jeremy, what's the difference between 8 and 15? 7, exactly. What, does anyone know the difference between 15 and 24? 9, 24 and 35? And 35 and 48? 13. So we know it can't be linear. The reason we know it can't be linear is because it's linear, these would all be the same. So we check and see is it quadratic. What's the distance from 7 to 9? 9 to 11? 11 to 13? 2. So we know it's quadratic. And when we know it's quadratic, what we must do is we must get a value for T1 and T2. So what I mean by that is we use our formula. So this bit's a bit tricky now, so make sure we're paying attention. This is our formula. Tn is equal to an squared plus bn plus c. And what we must find is a, we know already what's a in this one be? 1, because it's always half the second difference. T1 is equal to 1 times 1 to the squared plus b times 1 plus c. And I'm going to explain this now. This is our formula, it never changes no matter what we're dealing with. Is that okay? A, we said is 1. And I know what T1 is. I know what T1 is. Come up here. But I need to get a value for B and for C. Because it's my formula. So 1 times n, we said is 1. B times plus C is equal to 8. Just to start with this is a bit tricky. Anyone? 1 times 1 to be squared? 1. So it's 1 plus b plus c is equal to 8. Bring over my 1 is going to come out? Minus 1. b plus c is equal to 7. I'm going to box that off and put a little a around it. The next one, I'm going to do the exact same thing I did, except I'm going to do it for T2. This next one I said, I'm going to do it for T2. Your formula is still the same. an squared plus bn plus c. Except this time T2 is going to be equal to, what's 50? What's T2? 50. So 1 times, it's 2 to be squared this time because n is 2, because we're getting T2. Times b times 2 plus c is equal to 15. As I said, it's a bit tricky, guys. 1 times 2 to be squared, 4 plus 2b plus c. Bring the 4 over. Minus 4. 2b plus c is equal to 15 minus 4. 2b plus c is equal to 11. After this, guys, you'll be able to fight through it once I show it to you. But it's getting to here. So remember what to do. So I'm just going to run back through that again. Alright? We're all okay as far as getting the second difference. We know how to get the second difference. It's the next bit that catches me. So we know A is always what? Half the second difference, which this time is 1. Brilliant. So I get T1, which is 8. So that's 1 times 1 to be squared plus b times 1 plus c is equal to 8. 1 times 1 to be squared is 1 plus b plus c is 8. Bring over this 1, minus 1. B plus c is equal to 8 minus 1. B plus c is equal to 7. Box that. I did it for T1, and I'm going to go over and do it for T2. So T2. Formula doesn't change. It's still an squared plus bn plus c. So T2 is 1 times 2t squared plus b times 2 plus c is 50. All I'm doing is swapping in 2's instead of my n's, and I know my a is always 1 because it's half the second difference. So that's 4 plus 2b plus c is 15. 2b plus c is equal to, bring over to 4, 15 minus 4. 2b plus c is 11. We're nearly there, at least 15 minutes. So, before I show you how to solve it, I want everyone to get this far first of all. It's important to get this far first of all. Solving is very easy. You all get it. So what I want you to do is I want you to get me as far as here with this pattern. So 4, 9, 16, 25, and 36. Finding Tn. So off you go. 4, 9, 16, 25, and 36. Get down as far as here with that. Even T1, you can throw first term or first term this time is 4. Right? First term is 4. Right. Have a little look at it. So we'll do the first bit first of all. Dearman, what's the difference between 4 and 9? 5. Julianne, 9 and 16? 16 and 25? 9 and Grace, 25 and 36? Good stuff. Difference between all them is 2. So my formula is Tn is equal to An squared plus Bn plus C. What's A going to be, guys? 1. It's going to be 1 because it's half the second difference, and the second difference this time is 2. So, T1. What's A, guys? 1. N this time we're putting in 1 instead of N, so it's 1 to be squared plus B times 1 plus C. And what's T1 equal to be, say? 4. 1 times 1 to be squared is 1 plus B plus C is 4. That's B plus C is 4 minus 1. B plus C is 3. 3. Good stuff. T2. So our formula is still Tn is equal to An squared plus Bn plus C. Nothing changes there. A is still 1. N this time though is 2 because there's 2. B times 2 plus C. What's T2 equal to? 9, exactly. Because 9 is our second term. 1 times 2 to be squared is 4 plus 2b plus c is equal to 9. 2b plus c is equal to 9 minus 4. 2b plus c, what's 9 minus 4? 5. And we box that off. Right. Let's show us how to finish it. So, back to the question we just looked at. When we get that far, it's handy, because at the end of it, we're going to be able to fly through. Anyone even able to hazard a guess? Exactly, you're on the ball. How do you know it was going to be simultaneous? You can see it, because it's 2 letters and a number, letters and a number. So we're going to do a simultaneous. Exactly. Told you we'd fly through. 2b plus c is equal to 7, 2b plus c is equal to 11. I'm going to multiply my bottom line by minus, or change the sign to minus. Multiply by minus 1 or change the sign to minuses. Minus 2b, minus c, minus 11. Alright, what happens to my c's? They cancel. b minus 2b, minus 1b. 7 minus 11, minus 4, b is equal to 4. Take out our top line. b plus c is equal to 7. 4 plus c is equal to 7. c is equal to 7 minus 4. c is equal to 3. So simultaneously, did these before I went. Then my final formula was tn is equal to an squared plus bn plus c. It is now 1n squared. b I figured out to be 4, and c I figured out to be 3. Right, I want you to do this. The one you just did in your copies there. Finish it off. Get a value for b, get a value for c. Do a simultaneous on it. Don't forget to put it into your formula. Right, guys, let's have a little look at it. So, we were left at b plus c is equal to 3, and 2b plus c is equal to 5. So, b plus c is equal to 3. 2b plus c equals 5. So, we're going to multiply our bottom line by minus 1, or just change the sign of our bottom line. Must change them all. They cancel. b minus 2b is minus b is equal to 3 minus 5 is minus 2. a second. She's also got a bit dodgy. Happens from time to time. Change them all to a minus as I did. Minus, minus, minus. Minus b is equal to minus 2. B is equal to? Sorry? On the bottom line? Here? The red? Here? Because I don't want minus b, I want b. I want b. B plus c is equal to 3. B is 2, so 2 plus c is equal to 3. C is equal to 3 minus 2. C is equal to 1. So my Tn was an squared plus bn plus c. It is now Tn is equal to 1n squared plus 2n plus 1, and that's my final answer. And that's a tough one. That's about 15 to 20 marks on a junior pair. So one question, out the gap. Is that right? Last question of the day, guys. Our flu. Have a go at this one for me. Find Tn. So same thing again. 2, 6, 12, 20, and 30.
Wait, this is ours.
Yeah.
What the fuck is different? Wait, you do ours again? Does anyone know what to do?
Right, guys, let's have a quick look at it so before you get out the gap. 2 to 6 is 4, 6 to 12 is 6, 12 to 8 is 8, 10. 2, 2, 2. We all happy so far? Tn is equal to an squared plus bn plus c. So t1 is equal to 1 times 1 to be squared plus b times 1 plus c is 2. I think nearly everyone got it right anyway, so that's really good stuff. This is tough. b plus c is equal to 2 minus 1. b plus c is 1. t2 is 1 times 2 to be squared plus b times 2 plus c is equal to the second term, which is 6. 4 plus 2b plus c is 6. 2b plus c is 6 minus 4, which is 2. That's brilliant getting that far. And then it's just a simultaneous, guys. b plus c is 1. 2b plus c is equal to 2. Change the sign of our bottom line. Minus, minus, minus. They cancel. Minus b is equal to minus 1. b is equal to 1. Take out your top line or your bottom line, whichever one, it doesn't make a difference. b plus c is 1. 1 plus c is 1 because we figured out b is 1. c is equal to 0. That leaves us with a final answer of Tn is equal to an squared plus bn plus c, which is Tn is equal to 1n squared plus 1n plus 0. That's brilliant, guys, right? I'll see you next Friday. The homework goes up on a Monday and the corrections go up then the following week. What I would recommend to you, the 2E, is go back and look over some of the stuff we did in algebra. Just if you get a chance, and study. Alright? I'll see you next Friday, guys, right? Mind this. You're Dear McCanton, yeah? I was wondering as much. You've gone fair big. See you guys.